Intermolecular forces are forces of attraction or repulsion between two or more molecules. The prefix inter refers to the word between. This sounds very similar to, but is not the same as an intramolecular force. Intra means within, so an intramolecular attractive force would be something like a covalent bond, the sharing of electrons that makes molecules. There are three different types of intermolecular forces or interactions between molecules, and they vary in strength. The first one is a London dispersion force. This is due to momentary dipoles, which are small moments in time when the movements of electrons cause an uneven distribution of those electrons. So for a very short amount of time, electrons can be more on one side of the molecule than the other. Because all molecules have electrons, that means all molecules will have London dispersion forces. So normally an oxygen molecule that has a double bond between the two oxygens would have equal electronegativities for the two atoms, and we would say it's a nonpolar molecule. But there could be very, very short amounts of time where those electrons are not evenly distributed. So that means oxygen can have London dispersion forces or attractive forces between one oxygen molecule and another. Same thing for a methane molecule. Methane has carbon in the middle and has 4 hydrogens attached to it. In its tetrahedral arrangement, those hydrogens are equally spaced out, and therefore we have a nonpolar molecule. But it's possible that for a short amount of time, those electrons are unevenly distributed, and therefore we get London dispersion forces. The second type of intermolecular force is a dipole-dipole force. This is a stronger attractive force than a London dispersion force. This occurs when you have molecules with permanent dipoles, so molecules that are classified as polar. CH3F has a carbon in the middle, 1 fluorine, and 3 hydrogens. Because of that fluorine, this is a polar molecule. Electrons are permanently pulled up towards the fluorine. So polar molecules will be strongly attracted to each other because of the positive and negative distribution within the molecule. Same thing for hydrogen sulfide. The sulfur that's in the middle has a different electronegativity than the hydrogens. So polar molecule has dipole-dipole forces. The third type of intermolecular force is called a hydrogen bond. This is a strong attractive force between molecules that contain a hydrogen-nitrogen bond, hydrogen-oxygen bond, or hydrogen-fluorine bond within the molecule. Essentially, this is a really strong dipole-dipole force. So in water, oxygen in the middle, 2 hydrogens on the outside, very strong attraction for the electrons towards the oxygen means that this is a very polar molecule. If this was to come into contact with or come close to another water molecule, there would be a very strong attraction between the oxygen of one molecule and the hydrogen of another. Same thing for the second molecule, nitrogen, 2 hydrogens, and a chlorine. Nitrogen has the highest electronegativity, so it's the delta negative polar molecule, so it's very strongly attracted to other molecules with positive and negative sides, and that nitrogen-hydrogen bond means that it's an even stronger attractive force than what we might expect. So this contains hydrogen bonding. Hydrogen bonding helps account for some of the unusual properties that water has. It has a very high surface tension, which you can see if you look at something like a water strider, the bug that's shown in the picture on the right. Water also has a very high melting and boiling point relative to what we would expect based on its number of electrons. It has a high specific heat capacity, and water molecules and solids always form six-sided shapes. So ice and snowflakes, you'll quite often see six sides.